right, I think we are now ready to start. So welcome everybody to our webinar today. I'm going to be your host. My name is Kevin Young. I am the Chief Marketing Officer at Tools Group. And our topic today is probabilistic forecasting, what it is, why it matters in these times of economic uncertainty. And before we get started, just a little story to provide some context. We did a customer event last week. It was really great. It was at Harley-Davidson and the Harley-Davidson facilities. And we had, 35, 36 of our customers there. And the topic that came up over and over again was this challenging times that we find ourselves in, where demand is starting to slow, supply is freeing up. So those orders that have been in arrears are starting to come in, and inventories are starting to expand, impacting working capital. And that was the big topic of discussion. And in that context and that environment, improving the accuracy of your forecasts, being better with demand planning is really, really essential and critical. And that's what we're going to talk about today. And Angela, if you could go to the agenda, why don't we take a look at our agenda? First, I just want to say thank you to everybody who is attending. We have over 300 people who registered for this event. We've got customers, we've got who, by the way, thank you for being our customers. We're really glad to have you and hope you find this very interesting. You may have some things to add to help us, actually, because you've been doing probabilistic forecasting. We've got a lot of new companies who we haven't met with yet. We're super excited to have you here. We've got partners who are in the audience. We've got our employees in the audience. So welcome, everybody. This is going to be great. We've got over 43 countries represented online with us today. So good morning, good afternoon, good evening, depending on where you are located. And we're going to talk about what's coming up. First, a little housekeeping. And as a part of this housekeeping, let me just introduce Tools Group, because there's a bunch of people on the line who don't know much about Tools Group, I'm sure. You saw the invitation to this webinar, you're interested in the topic, but at Tools Group, we're leaders in AI-powered retail and supply chain planning solutions. And these solutions do a couple things really, really well. They help improve forecast accuracy, they help improve service levels, they help reduce inventory while maintaining those service levels. That's what we do. And really, it's all about achieving financial targets for our customers, but it's not just financial targets, it's sustainability objectives as well. And one of the customers I spoke with last week had a good line. They said, hey, it's about less waste and more profits. And that's what we're all about, less waste and more profits. And we've got decades of experience in very advanced supply chain planning techniques, and probabilistic forecasting is one of them. I would venture to say we were probably the first company ever to include probabilistic forecasting in our demand planning capabilities, and we've got tons of experience to share with you today. And then, Angela, if you wouldn't mind flipping to your picture, I've got the great pleasure to introduce our guest speaker here today, Angela Ciliberti from Tools Group. And Angela is our head of research in the analytical science and modeling areas at Tools Group. She's been with us for more than 10 years and is literally one of the world's most renowned experts in probabilistic forecasting. And so, Angela, I'll turn it over to you to take us through this. Oh, and let me just say one thing. If you have questions, by all means, put your questions in the chat. And if we get to the end, we've got time for Q&A. And then we will take the questions out of the chat and take it from there. And we will be recording this presentation, so everyone will get a recording when the presentation is done. So thanks again, Angela, and take it away.
Thank you, Kevin. Hello, everyone. Thank you to be here. I'm Angela Ciliberti. I've been working for Tools Group, as Kevin already told you, for more than 10 years. I'm currently leading the R&D team, which study and develop the forecasting and inventory optimization algorithm. I'm a mathematician, and I learned everything about about supply chain during my years here in Tools Group. Today, I would like to introduce you our probabilistic forecasting method, and I will show you why we believe that a probabilistic forecasting is the best approach, and in particular why which are the differentiator of our method compared with the standard approaches. But let's start understanding why we need an accurate forecast. I believe that the final purpose, the main goal of a supply chain manager, a supply chain planner, is try to understand and ensure to ensure that the right products or material are available at the right location at the right time in the right quantity to meet the customer demand with a nice service level, avoiding unnecessary and huge inventory levels. And in order to reply, to answer to this main request, we need an accurate forecast. Unfortunately, I often see clients and colleagues which are only focused to obtain the best forecast accuracy. And they use the forecast accuracy as the most important KPI. While we believe that we should look at the entire supply chain, we should understand which is the service level we are providing, and can we reduce the inventory cost, guaranteeing the same service level? In order to solve to this question, the forecast accuracy is absolutely the starting point. But for example, let's think a time series, a slow mover time series with a lot of period with zero demand. If you just focus on the forecast accuracy, maybe in some cases, some error metrics can give you the answer that a forecast equal to 0 is the best solution for this kind of time series. But you can easily understand that a forecast equal to 0 cannot be the right forecast to deal with the inventory calculation. The most used way to deal with the forecasting problem is to provide a number for each future period, which represent the best estimation of the demand and for that specific period. This traditional approach is called single point forecasting, and it provides a deterministic value for each future period. When this approach is used, it is assuming that the future demand has not any uncertainty. So we are completely ignoring the uncertainty in the demand. And maybe you can easily understand that this is not realistic. And in order to solve the issues that this assumption create when the inventory levels need to be calculated, some providers use empirical system such as the forecast error estimation, or they assuming that the demand will follow a normal distribution around the forecast. For sure, this approach cannot be called probabilistic forecasting. A probabilistic forecasting method provides for each future period not only a single point forecast, but the entire range of possible demand outcomes and the probability associated to each of these outcomes. So we are not talking about a single number. We are talking about the entire range of possibility with the corresponding probability values. This system, this probability distribution is able to lead all the decision regarding the necessary inventory coverage that is required to serve future demand and meet the service level. Because it's fundamental to know not only a number, but the entire range of values. Let me do an example. For example, when a single point forecasting provides you a unique number, means that is providing the expected value of a certain demand, a certain time series. But this is an information which is partial. You cannot say anything else, and you just know that the expected value of this particular time series is 6 units, like in this example. But I can show you many different demand distribution associated with an expected value equal to 6. For example, here I'm showing two different demand distribution with a mean and average equal to 6. It is shown with the red bar. And these two distributions are completely different. For example, on the right side of the screen, you see a distribution with a longer tail compared to the distribution in the right part of the screen. And this means that, for example, for the right part, the right side distribution, a demand equal to 20 has a probability to happen greater than 0. So you can actually receive a demand equal to 20. While if we look at the left side of the screen, 20 has a probability equal to 0. So it's not realistic receive a quantity, a demand equal to 20. At the same time, on the left side, the most likely value is equal to 5 or 4, while in the right part on the screen, the most likely value is 1 or 2. At the same time, we can see a higher distribution, a higher probability value associated with 0, the event to receive 0 demand in the right side, while in the left side, the 0 probability, it's almost 0. All this description that I just did is possible because I'm looking at the entire probability distribution. While just having a unique number, which is 6, I cannot say anything. And here it's clear that only having the entire possibility, we can lead an inventory decision. The probability forecasting the probabilistic forecasting recognizes the stochastic nature of the demand and describes future demand as a range of possible values and the probability associated with each one of them. Here I'm showing you the main screen in the demand forecasting screen of our software, where the forecast is represented by the red line, and for the future, you see these light blue candlesticks, which represent the probability distribution. Tools group probability distribution is a proprietary technology which has been specifically designed to describe the phenomenon of random demand. The main characteristics are 3. First of all, tools group probability distribution does not assume negative value. I will show you later that this is not obvious. Then a second important characteristic is the fact that the total demand distribution is strictly linked with the order line size distribution and the order lines frequency distribution. A third important thing is the fact that we are able to provide a reliable probability distribution for all demand types. So not only fast mover or slow mover item, but we are able to describe from very fast mover to lumpy and intermittent demand products. Here, for example, you can see the comparison between the probability distributions in quantity and order lines related with the fast mover item, and are represented by the top line graph, and the probability distributions related to a slow mover item, which are in the bottom part of the screen. It's clear that these two distributions, both in order lines and in quantity, are completely different when we are dealing with a fast mover product and when we are dealing with a slow mover product. A slow mover product especially for the order lines, it's almost, it seems to be an exponential, while for a fast mover, we have the entire bell. And it's clear that we are talking about a slow mover item because we see that the probability to receive zero demand is as the highest value. Now I would like to show you why a normal distribution is not the right solution to describe the demand phenomenon. Here, in this example, I'm comparing the two's group distribution, the dark blue line, and the normal distribution, which is represented by the red line. In particular, the two distributions have been created using an average of 2 pieces per month and a variance of 9. The first thing that we should notice is the fact that using a normal distribution, we are assigning a probability value greater than 0 to negative values. So this means that using a normal distribution, we are saying that it's possible receive a value equal to -2. So we are saying that it's possible a negative sales. A second important thing is the fact that we are talking about a slow mover item, an item which receive a lot of zero demand period, which has a lot of zero demand periods. And this is not clear if we look at the normal distribution, because the normal distribution assign the highest probability to the value of 2, so to the mean. While two's group distribution, first of all, has a 0 probability to receive negative values, and then it assigns the highest probability value to the 0 event, so the 0 demand. Until now, I was talking about the differences between a single point forecasting and a probabilistic forecasting method. I show you how the characteristics of our probability distribution. Now I would like to show you the main differentiators and capabilities of the entire forecasting system. We can summarize the capabilities of our probabilistic forecasting in 4 points. First of all, we are talking about a frequency-based forecasting system. This means that the forecast provided for the demand is not only based to the total demand time series, but it is also based on the order line frequency and their distributions to model the baseline demand behavior. Then it's a self-adaptive technology. This means it's a highly automated and self-adaptive forecasting algorithm, which is able to deal with the very fast mover as well as intermittent demand time series. It's a forecasting system which provides forecast for any aggregation level in terms of product hierarchies and in terms of market hierarchies. We also provide forecast at different time slots, such as monthly level, weekly level, and daily level. Last but not least, we have advanced machine learning methods to model various demand effects, such as promotions, new product launches, life cycle, price correlation, and other external factors correlations. Now I would like to show you some details related with these capabilities. Let's start understanding why a frequency-based forecasting approach is important. Let's start with an example. Let's suppose that we have product A and product B, which had the same sales quantity in the last 6 months. This is shown in the graph on the top, and you see that the two products have exactly the same sales month by month. But if we look at the order lines frequency, we see that the product A and the product B have a completely different order line size history. In particular, product A sales are spread over a large number of orders. So this means that the order line size is small. So the order line size is almost around 1-2 pieces. Vice versa, product B sales are concentrated in few order lines. And so the order line size is huge. So in this case, we can have order line size around 180. So now let's go back to our initial question. Should the planner plan the same amount of inventory for product A and product B to guarantee the same service level? Of course, if you are not using a frequency-based forecasting system, the simple answer is yes, because we are blind. We are not looking at the difference between the two products. But if a frequency-based forecasting system is used, then the right answer is no, because these two products deserve two different inventory levels. Let's see why. Here, I'm showing you the distribution provided by the system for product A and product B. Let's start from the bottom graph, which are representing the order lines distribution. Here, it's clear the differences between the two distribution. Product B is receiving an average order line number of order lines almost equal to 4, while product A has an average of order line equal to 40. So we are talking about two different distribution and two different average values. These differences in the order lines distribution are clear and are reflected in the total demand distribution. You can see, you just looking at the two graphs on the top. In the top, you see that the two shapes are similar but different, and in particular, the product B has a longer tail. So we have a probability greater than 0 associated to value greater than 200, while for product A, the probability to receive a demand equal to 200 is almost 0. At the same time, the probability to receive a 0 demand is high in product B, while it's almost 0 in product A. So this means that if we want to describe the behavior of product B is receiving as many periods with 0 demand, and when it receives demand, this demand is concentrated in few orders, and these orders are big. While product A is receiving demand almost every period with order lines with 1 or 2 pieces. So after this description, I believe that it's clear that product A and product B should have different stock levels. Now I would like to show you the self-adaptive technology capabilities. First of all, when we say self-adaptive technology, means that we are talking about a full automated technology. The model automatically adapts looking at the demand shape. The intervention required are minimal, while standard approaches usually require parameters that must be set. Another important capability is the fact that this technology reduce the risk of overfitting, increasing its prediction capabilities. So we have a good predictability, while standard approaches try to select optimal model, minimizing the error, the past error. Using this technique, you are increasing the overfitting risk, and maybe you are reducing the prediction capabilities. For example, I was thinking to this example. A few days ago, I was playing with my son. He is 2 years old, and I was hiding a marble in my hand, and he had to guess in which hand the marble was. We did several runs, and every time I was switching the hand, so before in the right, then left, right, and left. And he was always selecting the end where the marble was in the previous run. So he was not able to understand the model behind my decisions, because the pattern was clear, but it was the base of his selection was the fact that he was selecting the hand where the marble was in the previous run. So he was reducing the error with the pass, but he was not able to do a good prediction. So maybe we should wait some year to be able to help me in the forecasting method. And then a third important capabilities is the stability, because the model smoothly adapts the prediction to change in demand behavior, eliminating the risk of a drastic variation in the future forecast. While a standard approach, usually when they see some changes in the demand behavior, they can modify completely the model, and this can cause a completely different forecast for the future. Here I prepared an example to show you how the self-adaptive technology modifies the prediction when the time series is modifying the behavior. This product is a slow mover product at the beginning of the history. Then in the central part of the history, we reduce the interarrival time, while at the end of the history, we have a demand greater than 0 every month, and actually also the quantity is increasing. I ran the forecast 3 times. The first time using the history until the 9 months, the second time using the history until the 13 months, and the last time using the entire time series. And the results are represented by the 3 lines from light to dark blue. And you see how the system, without changing any parameters, is smoothly following the change in demand. The entire forecasting system can be described as a structure with 3 different layers. The base forecast is computed using the self-adaptive statistical forecast, and it's the base forecast is the foundation of the entire system, and so it's very important. Then on top of this base forecast, we have the forecast shaping. And using some machine learning engine, we are able to add some intelligence, and so to add the seasonality pattern, the external variable knowledge. We can add the promotional effect and the launch effect. And then the third layer is representing by the market intelligence. We believe that there are some information that only the who knows the business can add to the system. For example, if you receive an exceptional order, it's something that the system can automatically know. And so it's important to add this knowledge to the system in order to keep the forecast as stable and reliable as possible. As I told you before, we have many machine learning methods which are used to shape the forecast and to model some particular effect. First of all, for example, we use clustering and classification to group the items with similar seasonality patterns. We compute the day in week seasonality, the week in month seasonality, and the month in year seasonality. Then we use a classification system to understand the relation between these groups and the attributes, and only in this way we are able to assign a seasonality group to a new product. We also have the new product introduction algorithm, which is able to create a prediction for the future for an item which has no history. And so we know only the characteristics of the item and the market characteristics where this product will be sold. We also use clustering and classification system to model the promotional effect, such as we group promotion with similar behavior, and then we try to understand the correlation between this behavior and the promotional characteristics, the promotional attributes. And knowing the promotional attributes of a future promotion, we can assign to a future promotion the right profile. We then use the point of sales information to improve the sell-in forecast. We study the correlation between some external variables and the demand, such as weather data, price level, media, advertising, and so on. And also we are able to model a life cycle, the life cycle profile for items which has a short history. In the last part of my presentation, I would like to show you some case studies. The first one is related with Aston Martin. They asked us to improve the first time availability service level across the three categories of their product: the heritage, the recent production, and the current production. We were able to increase the service level to 97%, which was above their target. And at the same time, we were able to reduce the inventory value. All of these goals were reached improving the forecast accuracy. And in particular, in their case, the improvement were related with a better seasonality and seasonality modeling. They used also the seasonality clustering algorithm. A second case study is related with the Tool. Tool was founded in Sweden. It's another famous company, and their demand is highly seasonal and intermittent. And when they started using our software, their service level was slightly below 80%. Using S99, they were able to increase the service level from 80% to 92%. At the same time, they lowered inventory investment. And using this system, they were able also to better control the complex network and have a better visibility on the network using a more effective reporting system. A third example is the most recent one. It's related with a company which has been found in Spain. It is called Gaviota. It's a worldwide company, and they sell systems for rolling shutters, and Gaviota is the market leader in sun protection. They raised, also for them, they were able to provide a better service level. They raise the service level up to 95% for top items, and they improve the service level also for all the other products. At the same time, they were able to reduce the stock levels and improve their production performance. And using a unique system, they were also able to synchronize all the departments. What's next? I don't want to list you all the features that we are working on or we are preparing for the future version, but I would like to share with you our philosophy. I think that in Tools Group, the innovation and research, it's always central. And as I told you at the beginning, I started working for Tools Group more than 10 years ago, and now it's not usual to have someone in the same company for so long. And I think that the main reason why I decided to remain in Tools Group is the fact that here we have the possibility to improve the product and do a lot of research. Thank you.
And questions. So if anybody has a question, thank you, Angela. I feel like clearly you are the expert. You need to work on your son. He needs a little more. He needs a little more help, but you are the expert. Let me just say before we get into the questions, and we've got a couple of already that have come in, is again, put your questions in the chat if you've got a question. Let me just say that we would like to meet everybody who's been on this call. I mean, we covered this really quickly, right? In 35 minutes, you can't do justice to the topic of probabilistic forecasting and just all the ways in which you should think about managing your demand. And so one of the things I'd like to offer to everybody is that we'd love to have our consultants meet with you. I'm happy to meet, happy to talk, happy to give you a demo, show you how this works, happy to talk about your process and help you think about better ways to manage the process. And so we'll send everybody an email as a follow-up. In the email will be a link to request a meeting with one of our consultants or a demo. Please take us up on it. We would love to do that. We'll also send you a recording of this presentation. So now let's get to some of the questions. So the first question is really like, this is really complex stuff. Do you need to be an expert in statistics in order to use the probabilistic forecasting in Tools Group and SO99?
Absolutely not. The probabilistic forecasting, as I told you before, it's a completely automatically model, and the probability is used by the system to in the inventory part of the system to achieve the target service level, calculating the right stock levels.
Now here's a question that just come in about lost sales, and the question is: do you think that lost sales can be quantified better with probabilistic forecasting?
Yes, absolutely yes. Because using a probabilistic forecasting, we can control the inventory, and so we can reduce the lost sales. Or if you wanted to reach a high service level, this means that we can reduce the lost sales.
Great. And another question. This is how do other departments like inventory or production stay aligned if there isn't a single number forecast?
It's the departments are aligned mainly because we have not a single point forecasting, but we have a probabilistic forecasting because during the inventory calculations, the system needs all the possible outcomes with their probabilities, and only in this way we can lead the inventory decisions.
Great, thank you. And then here's another good one. So in a simple time series, if the sales trend has too much variability, how can we tackle that without using machine learning algorithms?
Sorry, can you say again?
Yeah, so if there's lots of variability, I guess the question, if I would put it another way, if you have a highly variable intermittent demand product, but you didn't have probabilistic techniques or machine learning, could you come up with an accurate forecast?
I believe no, because we need it's not enough to come up with a probabilistic forecast with an accurate forecast if we are not able to provide the entire probability distribution.
Yeah, I would agree with you. I think that was one of the reasons why our system was built the way it was built, was to handle exactly that situation. These products that have intermittent demand and are quite difficult to forecast. Here's another question, and maybe I could just answer this one for you, Angela. How does the tool work with current ERPs or systems like SAP, IBP? And the answer is that, we're fully integrated into those systems. So those are the systems of record where a lot of the data that we use comes from. So we integrate into, pull the data and can also push data into those systems. And that's the scenario we find ourselves in with every customer, right? Every customer has some system of record, some ERP system that we need to interoperate with. And so we work with all of the major vendors. Let me look down our list. We've now got a bunch of questions that have come in. So would the model forecast unconstrained demand, even if you don't have supply to meet the demand? So I guess really the question here is the connection between the forecast versus what can the suppliers actually supply.
I'm looking for this question, sorry.
And I think part of the answer, if I would just start for you, is that there's, our system manages demand, optimizes inventory, and then manages the replenishment process. And it's in the inventory optimization, the supply planning, and the replenishment planning where the constraints come into effect.
Yes,
demand,
exactly.
the demand is demand. We want the demand to be as accurate as it can possibly be. Now, whether your suppliers can fill the demand, that becomes a different set of decisions that you need to make. So you're not going to change your demand forecast based on supply that's available, but you do need to change your supply plans based on the constraints that exist, which is an awesome introduction to the next webinar that we're going to do. And the next webinar is going to be around supply planning, and it's going to be around the use of advanced statistical techniques, including probabilistic techniques in supply planning, because that's kind of the next area that you need to tackle. Right? You got to get the forecast right. You got to figure out how you're going to get that forecast supplied, and you got to figure out where then it needs to be placed. I've got another question for you, which is this next one. Some of these are a little hard to. We've got there's a couple questions here we're going to have to, and we're happy to answer, and we'll follow up. There's some very specific questions. They're going to be tough to answer generally.
Yeah, maybe we can send some answer later.
Yeah. Okay, here's a good one, because we have many customers who are in this situation. Would it make sense to apply probabilistic forecasting in a make-to-order or assemble-to-order environment?
Yes. Yes, it makes always sense to apply probabilistic forecasting.
Yeah, I think that's what we found. We have
we are
many
touching a lot.
customers who are in that situation.
I'm seeing other question. Maybe they need a longest reply, because some question, in order to be replied, I have to also to explain the policy that we use for the inventory, because we have also a different policy compared to what the literature says. So maybe we need another webinar on this.
Yeah, I think that we do. And I think that there's, like I said, we would love to meet with everybody in individual one-on-one meetings. We can bring Angela in if you want to talk technical questions. We can bring our consultants in if you'd like to speak about more business type issues or see the product. So, and the next webinar, which is coming up, we'll send you keep your eyes on your email. We'll invite everybody here to come back and learn more about what we're doing in the, how to use these sort of advanced techniques in supply planning. So let me just say it's 11:04. Well, we're in the East Coast of the United States. Angela, you're in Milan. We have people here in Asia and in Latin America and all over the world. So we promised a 45-minute webinar. We're at our 45-minute limit. So thank you again.
Let me just to do a last reply. Sorry, Kevin.
Sure.
Yes, the probabilistic forecasting work on both short lead time and longer lead time. Also because the lead time, when we compute the lead and demand, we try to it's is there where we use the probability computed by the forecasting.
Thank you.
Sorry.
No, good. That's great. Last question under the wire. All right. Well, everybody, again, thank you so much for joining us. We really enjoyed it. This was the first of our educational series for the year, and we're going to do a bunch of these because I think there's a lot everybody is interested in learning, and we're very happy to share. So thank you again, and everybody have a great weekend. Oh, I see all the little claps. I love that. Thank you very much.
Thank you. Thank you.
Okay. Bye, everyone.
Bye.